This is the latest calculator that I'm releasing to the solar industry. It calculates wind uplift forces on flush-mounted arrays, be they photovoltaic or solar thermal. As with all of our calculators, all of the yellow parts are editable and changeable, but the not highlighted parts are locked down in the free version. So I'm going to talk about codes a little bit at the end because that's the boring part and I don't want to scare you away. But suffice it to say that if you're going to be following along with this, you're going to need a copy of ASCE 705. The reason for that, all of these selections here that are highlighted are many of them based on tables and figures and sections from that book. The first of those is the exposure category. The exposure category is basically the type of terrain surrounding your structure. So if you've got really obstructed terrain, you're in an urban area with lots of high-rise buildings, then you're very clearly in category B. If you're on the other extreme, you're in category D, would be if you're right on the beach and the wind is coming off of the ocean, you're going to be experiencing the highest wind loads. And these terms are very technically defined, so you're going to want to go to the appropriate section in the book and figure out which exposure category you're in. Once you figured that out, you're going to need to figure out your occupancy category. That ranges anywhere from the least important, agricultural, to the most important, which is emergency. Now, if you're doing a calculation for a house, it's pretty typically going to be residential, but again, go to table 1-1 and make sure you're choosing the right version, the right occupancy category. There are many different types of roofs, but this calculator covers 3 of the 4 most common. That's gable, hip, and monoslope. The one that this calculator doesn't cover very well is flat roofs. If you want to use this calculator for a flat roof, choose the gable/hip, but do realize that these values are going to somewhat overestimate the actual uplifts that you're going to be experiencing. There was a good article in Solar Pro that describes a better method for calculating uplifts on flat roofs, and I'm going to be linking to that in the video description. So once again, if you're doing a basically monoslope with pitch less than 3 degrees, then choose gable/hip. If you were in this calculator to choose monoslope and then enter in a roof slope that was 2 degrees, then you'll see that you're going to get errors. So you're going to want to have to choose the gable hip for that. The next section that you're going to have to fill out is the 3-second gust speed. You're going to pull that from the map, which is figure 1. In California, that's typically going to be 85 miles per hour, but in other parts of the country, that gets as high as 120. These figures 6-11 to 6-16 are going to show you your roof zones, and your roof zone diagram is going to be different based on which type of roof you're looking at. The 3' and the 2' only exist for monoslope roofs. So if you're doing gable hip, then you're only going to be choosing one of these 3. So the tributary area, you're going to want to fill out. If you don't know what tributary area is, definitely look it up. It's a very common concept. I find that 10.7 square feet is fairly common on these sort of systems. The next section you want to choose is the least horizontal dimension. So if in plan view, which is what you would see if you were in a helicopter above the house, then if your house was 55 feet by 35 feet, you'd want to enter in the 35 feet here. Once again, roof slope, it's going to be 18 to 20 degrees very frequently. And mean height of array above ground is pretty self-explanatory. If you've got a 1-story building, this is frequently going to be between 10 and 14 feet, depending on how much attic space you have, but if you have multi-story structures, it'll go up from there. These calculations here, if you want to follow along these calculations in the ASCE 7, I've included references for everything that was done here, so it should be really easy to follow along with these calculations and verify that they're working correctly. And I can't promise that they are working correctly, so you should definitely double check. Anyway, you've got the pressure up and the pressure down. Those are listed in pounds per square foot. So in some of my other calculators, this is going to be a value you're going to need to include. And then if you've entered in your tributary area, basically these values are just these pressures times the tributary area yields these results. And finally, the calculations being run by this calculator are limited in a number of ways. So those assumptions are listed here. As you can see, there are many of them. So they're pretty self-explanatory, and I'm not going to read them off to you. Okay, so now we're entering in the boring part where I talk about codes. So if you just, if you know about codes, stop watching. This calculator is only going to be valid in California for the rest of 2013, and the reason for that is that as of 2014, California is switching from the International Building Code 2009 to the next version, which is 2012. And when that switchover happens, also the ASCE 7 is going to switch over from the 2005 version to the next edition, which is 2010. So since this calculator is based on ASCE 7 2005, it's not going to work for the next book because they changed things. The company or the organization, it's a nonprofit, I believe, that releases the International Building Code is the International Code Council. They also produce acceptance criterias, one of which is acceptance criteria 428, in which they talk about what calculations should be run to verify a photovoltaic system. In it, they specify that you should use this particular method, and you'll find this method in the ASCE 705. That method is what these calculations are doing. So if you have the book and you use these calculations as a guide, it should be pretty clear what's going on. And as of next year, we're going to have a different calculator. So I believe that's all I've got to say about this calculator. So thank you for watching this video, and I hope you enjoy using it.